Hello everybody and welcome back. Root Beer here with question number 24 now on the 2004 grade 9 Pascal paper put out by those fine folks at the CEMC at the University of Waterloo. In the sequence of fractions, okay, what have we got here? 1 over 1, 2 over 1, 1 over, so they're clearly not going for fractions that are in reduced terms, that's fine. 1 over 1, 2 over 1, 1 over 2. 3 over 1, 2 over 2, 1 over 3. Oh, I see. So we sort of start with the number 2, and our fraction top and bottom add up to 2. And then we start with 3, and then we get 2 over 1, 1 over 2. And then the next 3 add up to 4, the next 4, the top and bottom add up to 5. And so, okay, I see where we're going here. So in this sequence of fractions, fractions equivalent to any given fraction, that's a lot of the word fraction in that sentence, but okay, occur many times. So for example, the fractions equivalent to 1/2 occur for the first 2 times in position 3 and position 14, which is not shown. It would probably be with 6, which is coming up. It'll be 4 over 2, then 3 over 3, then 2 over 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then we'd have 4 over 2 is 12, 3 over 3 is 13, and 2 over 4, yeah. Okay, so I agree. Okay. In which position is the 5th occurrence of the fraction equivalent to 3 over 7? Okay. What can we do about this? Okay, so for people who didn't catch on verbally, I'm actually going to extend the sequence and show that the 3rd position and 14th position are both fractions equivalent to 1/2, and maybe we can get a little better of a sense of what's going on. So, oh, we're still on blue from the last question. Silly me. Silly me. 1 over 1, and then I'm going to sort of group these a little bit. We do descend, correct? Yeah, we descend. Okay. And then 3 over 1, 2 over 2, and 1 over 3. So you notice I'm leaving out some commas. I'm grouping. These ones add up to 2, the numerator and denominator. These ones add up to 3 if you add the numerator and denominator. These ones add up to 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. And then we'd have 4 over 1, 3 over 2, 2 over 3, 1 over 4. These guys add up to 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm also noticing each group takes it. You know, there's 1 way to add up to 2. There's 2 ways to do the 3. There's 3 ways to do our group of 4. 5 over 1, 4 over 2. So that's 11, 12, 13, 14. So this one here and this one back here, they've said, yeah, these 2 are equivalent. Okay. And then finally 1 over 5. These ones are 6, and there's 5 of them. Okay. So what I've noticed is we can group our fractions. There are sort of n minus 1 of them. There are n minus 1 fractions p over q, so that p plus q is equal to n. Now we start with n minus 1 over 1, and we work our way down to 1 over n minus 1. Okay, so we have a general sense of the pattern. Great. Now we're being asked to sort of find ways that we can write 3 over 7. And I think we want the 5th version. I think we want the 5th. Which position is the 5th occurrence of the fraction equivalent to 3 over 7? Okay. Well, we don't have a lot of experience here with fractions that are equivalent to the other, but let's take a look with what we've got written out, what fractions are equivalent to each other. So I'm noticing we have a lot of fractions equivalent to 1. We have 1 over 1, we have 2 over 2, and we have 3 over 3. These are all equivalent to 1. We have, I'll just do these in green so they stand out, we have 2 fractions equivalent to 1/2. Do we have anything else? We have 2 fractions equivalent to 2, and I think that's it so far. So what can we get from this? So the fractions equivalent to 1, they have to be sort of p over p. In which case, then, we're looking at a group whose sum is 2p. So 1 over 1 is equivalent to any sort of fraction that looks like p over q, p equal q. And that occurs in any group with n equal to p plus q, but since p is equal to q, we got p plus p equal to 2p. So any n even would do. Okay. How about our 1 over 1/2? Well, that's going to be equal to any p over q, where twice p is equal to q, because then this would be p over 2p, and the p's cancel out, giving us 1/2. Okay, so that occurs when n is p plus q, and q is twice p. So we get 3p. So any n that is a multiple of 3. All right. And what else can we see? We've got the 2 over 1 case. So we multiply those. So we bring the q over to the other side. 2q has got to be equal to 1p. Of course, we just write that as p. And so our n's here are p plus q, which has got to be equal to 2q plus q. So again, multiples of 3. So where would the first 3 over 7 occur? That's something that I want to figure out. So 3 over 7, we'd get sums up to 10. And we'd have, 2 over 8 is next, and then 1 over 9. So we'd have to start with 9 over 1, 8 over 2, 7 over 3, 6 over 4, 5 over 5. Hey, there's another copy of 1 there. And 4 over 6. So that's the first occurrence of 3 over 7. If we had another occurrence of 3 over 7, then we'd see 3q, just cross multiplying, 3q is going to have to be equal to 7p. That's not especially helpful for us, but we know, I suppose we could write q is 7/3 p. And then n is p plus q, right? So that's p plus 7/3 p. And so that's 3 over 3p plus 7 over 3p. You're going to have to move over to the other side, but basically we get n is 10/3 times p. Okay, so p is divisible by 3. We already knew that, but the point is, the only way to get an integer here is sort of 3n is equal to 10p. We can rearrange like that. And so 10 is equal to 2 times 5. Break it down into prime factors, and this is why. If 3n is equal to 10p, then 10 must divide 3n. But 2 divides 10. So 2 must divide 3n. Now 2 doesn't divide 3, and since 2 is prime, that means 2 must divide n. So similarly, 5 must divide n, and we conclude that 10 must divide n. You could have jumped to that by saying 10 and 3 have a greatest common divisor of 1, but I'm not going to assume you know that stuff. I will assume that you should know if P is prime and P divides some multiplication, A times B, then either P divides A or P divides B. Possibly both, but one of these must happen. This is one of the sort of defining properties of prime numbers. Okay? Very fundamental concept for prime numbers, something you should know. Okay? So basically we've got 10 must divide n. I'm betting that's the only condition here, because if we have 3 over 7 is P over Q, we'd have to have some sort of common factor. And so we'd have to be able to say P is 3K and then Q is 7K, right? So then N is P plus Q. It's got to be 3K plus 7K, 10K. So I guess that's a quicker way of saying that N has to divide 10. But that's it. So we'll have N is 10 gives us something, then 20 will be the next one, 30, 40, and we want the fifth case. So we want our N's to sum up to 50. Okay. So now we can start talking about where this copy will appear. So we've done everything, we're all the way, and then we start the things that add up to 50. So we got 49 over 1, 48 over 2, and what's going to be the thing that goes 3, 7? How do we split? 50 is equal to 3K plus 7K, so 50, so 10K, so K is equal to 5. So we're going to have P is 3K, P is 15. And Q is going to have to be 35. So, we're going to go all the way down to 15 over 35. So, now what's left in the problem is we've got two calculations to make. We need to sort of calculate, okay, what's the last, what position is the last thing we hit before we start doing 49 over 1, 48 over 2, and so on. And then once we've gotten that number, say it's like 100, where is 15 over 35 in this lineup? Okay? And, if it's the seventh, I know it's not the seventh position, but if it's the seventh position over, then 100 plus 7 will have the 107th position. Okay? So that's two things we need to do. Okay? So I'm going to figure out where is 15 over 35 in this group. What position is he? Is he the 7th position? Is he the 10th position? What are we talking about? So it's actually not that hard. I was looking at the numerators and thinking, geez, this is going to be kind of hard because I'm going to have to count backwards or something. But really, the first one is the one that's 49 over 1, 2, and so it's the 35th position. Okay. So now we sort of need to count the groups. So the group that adds up to 2, that's 1 over 1, there's only one of those. And then the groups that add up to 3, there's 2 of those. And then there's 3 that add up to 4, where the numerator and denominator add up to 4. There's 4 that add up to 5. So before we hit position, the things that add up to 6, there's 10. And say I wanted that 2 over 4. I know 2 over 4 is in there. He's 5 over 1, and then he's going to be the 4th position. 10 plus the 4th position, we do get the 14 that was predicted. Or we've predicted now 14, and that really is, they told us, the position where 2 over 4 is. So how do we work this out? So really we want 1 plus 2 plus 3 plus all the way up to, so these are the guys who add up to 50, so before him is the guys that add up to 49, and there are one less, so there's 48 of those. So we have that, plus 35 will give us the answer. Okay. Now we could grab our calculators, or we could remember, if you haven't seen this formula, I'm going to show you a great formula, we could remember how to add up the sum of the first so many natural numbers. 1 plus 2 plus 3 plus 4 plus 5, all the way up to plus n. And we can pick whatever n, and we have a formula for that. See, I haven't seen it before. It's great. I'm not going to prove it. Maybe I'll do a video about that at some point. But it's a great formula. I suggest if you don't already know it, if you want to learn more about it, I would sort of Google sum of the natural numbers or use whatever search engine you want. But we add all these up. This has a formula. It's n, whatever n you choose. You want to end at 10, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, 8 plus 7 plus 8 plus 9 plus 10. You would plug in 10 here. N times n plus 1 all over 2. Okay? So, for example, if we wanted 1 plus 2 plus 3 plus 4, I know that this is 10, but we'd have 4 times 4 plus 1, which is 5 over 2. That's 20 over 2. That is 10. So what we want is adding up all the way to 48, and then adding on the number 35. So this will be 48 times 48 plus 1, which is 49, all over 2 plus 35. This is the calculation we need to make now. 2 and 48, we have 24 times 49 plus 35. And I'm not really going to bother to do that in my head. I've got my calculator here. Why not use it? So we have 1176 plus 35. So I know this is going to end in a 1. We'll just add it on with the calculator anyway. 1211. So I really hope that's one of the answers here. And there it is. It's the last answer. Okay, I feel pretty good about that. Something I would have done, I don't like this array of answers. Something I would have done is, assuming that you maybe didn't count the 48 right, and you should have thought that maybe this should have a plus 49 in there. If you were just lollygagging about and weren't keeping everything on task. But, yeah, it's fine. So we have an answer here of E. Okay. Not bad at all. Just double checked. In what position is the fifth occurrence? Okay, so it all works out. We even were able to double check our hypothesis of how are these positioned by figuring out where 2 over 4 is. It's 10 plus 4, 14th position. And they even told us that. Nifty. Okay, so we've got one more question left on this contest, and that would be question number 25. It's got some triangles in it. Hopefully it'll be a good question. And I'll be tackling that in the next video. So long for now, and have yourself a wonderful day.